Firstly, let me start with introduction to integration. What is integration? Integration is a method of adding or summing up the parts to find the whole. It is a reverse process of differentiation where we reduce the function into two parts. Basically, this method is used to find the summation under a very large scale. Another question: why we use integration? Integration is used to measure things such as area, length, volume, and many more. It can also be probabilities in context of unplanned variables. We also use it for big addition problems where the limits could reach to even infinity.
My name is Atila. We will continue this part. Problem statement, what to solve. So this is the question and the diagram. A. Find the coordinates of P and Q. The WTS is coordinate P and Q. So number 1, we have two equations given. Number 2, write in terms of X. We will get two equations of Y. Number 3, make it equal. We will get X. And lastly, substitute X into any of the equation Y. We will get coordinate P and Q.
My name is Atya and I will be showing you what to solve for question B, which is find the area of shaded region R. There are two methods to solve area between two curves. I'll be showing you how to determine the area between y equals to fx and y equals to gx. For this method, the formula is integral from a to b f of x minus g of x dx. What is a, b, fx, and gx? A equals to the lower limit, b equals to the upper limit, fx equals to the upper function, and gx equals to the lower function. For this question, first of all, we should determine the cross-section of the shaded region. For this method, the cross-section will be parallel to the y-axis, as we can see from the graph. From here, we can determine the integral is in terms of x, as we can see from the formula. Next, we can determine the value of a, b, fx, and gx. After finding the coordinates of P and Q, we can get the value of A and B from the x-axis. The upper function is the function that touches the top of the arrow. Meanwhile, the lower function is the function that touches the bottom of the arrow. After substituting the values into the equation, we can use integration to get the shaded region R.
Here I will show you the second method using parallel to x-axis. Number 1, draw the arrow which is to the right. So the orange one, top and bottom touch same line and curve. The blue one, top touch curve and the bottom touch curve also. It shows that not only one integral. Number 2, divide the region into 3 parts. Number 3, do the integration for R1 or R2 and R3. Number 4, find A and B for each integration. A and B is the limit. How to find the blue arrow coordinate is using y-intercept from the curve equation. Number 5, use this equation for integrate. Number 6, substitute the point in the correct place. Fy for curve, gy for straight line. And lastly, R1 or R2 times 2 and plus R3.
Hi, I'm Atira and I'm going to show you the problem solution. The question is, the region R in diagram below is bounded by the curve y equals to 6 minus x squared and the line x plus y equals to 4. So here is the diagram that has been given. Question A asking you to find the coordinate of P and Q, and question B asking you to find the area of the shaded region R, which is from the diagram, it is the one that has been colored by the red color. But before we move on to the solution, we have to identify the direction of the arrow. From this diagram, the direction of the arrow is pointing upward. Question A asking you to find the coordinate of P and Q. So y equals to 6 minus x squared is equation 1. X plus y equals to 4, bring x to the left and it becomes y equals to 4 minus x, which is equation 2. So substitute equation 1 into equation 2 and you'll get 6 minus x squared equals to 4 minus x. Bring 6 minus x squared to the left and it becomes x squared minus x minus 2 equals to 0. Factorize this equation and you'll get x equals to 2, x equals to negative 1. We have not done yet because the question asking you to find the coordinate. Therefore, we have to find the value of y. When x equals to 2, substitute x into any of the equation. So we choose equation 2. So y equals to 4 minus 2, y equals to 2. When x equals to negative 1, y equals to 4 minus negative 1. So y equals to 5. Therefore, the coordinate of P is negative 1, 5 and the coordinate of Q is 2, 2. Question B asking you to find the area of the shaded region B. Formula for the area of the shaded region is integration from A to B fx minus gx dx. From the previous question, we know that the value of A is negative 1 and the value of B is 2. The value of fx is 6 minus x squared and the value of gx is 4 minus x. Next, we are going to substitute all the information into the formula and it becomes integration from negative 1 to 2, 6 minus x squared minus bracket 4 minus x dx. Now we can simplify this equation into integration from negative 1 to 2, 2 minus x squared plus x dx. Next, we can start integrate the equation into 2x minus x cubed over 3 plus x squared over 2 from negative 1 to 2. Next, substitute the value of a and b into the equation that we have integrated. After substitute the value of a and b, we are going to get 10 over 3 minus negative 7 over 6. And lastly, you'll get the answer 9 over 2 unit square.
As a conclusion, after watching this video presentation, you should be able to understand the basic concept of area between two curves. Next, we can identify which cases required to find the area between two curves, and we also could apply the definite integral method to find the area between two curves. By using integration as mathematical techniques, we have been able to reach the solution by the methods used. The methods brings a very simple and clear way. Plus, it is very important as mathematical tools because it is used in many fields such as business and also help to estimate things like marginal cost, marginal revenue, profit, gross loss, and also can calculate center of mass and gravity. By doing a lot of exercises, it may help you mastering in this topic.